Hello geometry students, and welcome to the continuing lesson on the side postulate. And here we have a problem that says determine whether triangle ABC is congruent to triangle DEF and explain your reasoning or give a proof. And so this is somewhat of a different problem than what we've seen before. We don't know if it's congruent yet. We're not asked to prove that it's congruent because we don't know if it is. We're just going to look at this and see if it is. Okay, so at first look at this, I have a side here, so let's list out some sides. Okay, that's what I always like to do. I know that AB is that's this triangle, that's triangle ABC. So AB from the picture that it tells me is equal to 10. AC is equal to 8. Okay, and I don't quite know what BC is equal to. That's the thing. Okay, so BC, I'm not quite sure what that's equal to. Okay. Now looking at the other triangle, let me use a different colored pen here because that'll illustrate things a little better and makes things interesting, at least. I look for another side that's also equal to 10. So DE, that is also equal to 10. And so is, looking at DF, okay, that's equal to 8. So this would suggest that I should use side because I already have two known sides that are congruent. Now I just need to figure out what about that third side? What about EF? What is that equal to? Well, let's see here. Let's go back to BC for a moment. So let me get my highlighter out. So hopefully we can see here, if we are looking at BC, so that's this section right here, okay, BC. We have a part of BC that's equal to 2, and then the other segment is equal to BF. So BC is equal to 2 plus BF. This part here is 2, this part here is BF. Then let's look at EF. Let's look at EF. Okay, so if we look at EF, let me get a better marker here. I can do better than this. So that's this section right there. EF is 2, that's this segment, plus BF. So from this picture, it should be rather clear that these two triangles are in fact congruent. So yes, okay, triangle ABC is congruent to triangle DEF. Okay, that's our final answer. But it also says to give a proof. Well, this shouldn't be too difficult to show. Okay. So it's going to take me a little bit of writing here, but that's okay. I can certainly do some writing. So I can make a statement and reason. So first, I can say that AB is equal to DE. And this is the transitive property since both is equal to 10. AB is 10, DE is 10. That's the transitive property that I'm using there. Okay. I can also say that AC is equal to DF. Okay. And same thing, it's also the transitive property. They're both equal to 8. Now I need to explain this part a little bit because if you look at this, it seems like it comes out of nowhere, but it shouldn't be too difficult. I can say that, look, this segment here, FC plus BF equals BC. Right this way. BF plus FC equals BC. And this is the segment addition postulate. Okay, so this is why we learn these phrases and these terms so that we can use them quickly. We know that FC is equal to 2. That's given. Okay. Therefore, BF plus 2 is equal to BC. And that's basically the same statement that we have up there. And this is substitution. Okay? And now this proof gets a little bit lengthy, but we can get it done. Let's look at the same thing for EF. Well, for EF, EB plus BF equals EF. EB, so that's this part right here, plus BF, that's equal to EF. And this is segment addition postulate. Okay. But EB is equal to 2. And that's given. And so now we can take this and substitute it back in there. So 2 plus BF equals EF. And now we have these two statements. That's the same thing as what we have up here. So if we use statements 5 and 8, we get that BC is equal to EF, and this is the transitive property with statements 5 and 8. Now, when you do proofs, notice that I list out the statements that I use in order to make up the new statement. You don't have to do that all the time because that's not necessarily helpful all the time, but here when I have a longer proof, it's very helpful for me to be able to identify, well, what two equations am I using in order to get the third. And finally, since I have three sides, I have that side, and this side here. 1, 2, and 9, I can say that triangle ABC is congruent to triangle DEF, okay, using 1, 2, and 9. This is side, side, side. And so there you have it. These two triangles up in this picture here are in fact congruent to each other by side, side, side. Alright, so we'll end this video here, and I will continue one more video where we look at this problem and see if these two triangles are in fact equal to each other.